What's up guys, MizzoFrizzo from Pitchfork Academy here, and in this Unreal Engine 5 tutorial I'm going to show you how to set up the basics of a 2.5D side-scroller with a fully procedural camera system. So as you can see here, I've got a side-scroller set up. I can move through my level, and this procedural camera system has a few mechanics such as locking the height of the camera to a certain plane. So for example, up here, it's locked to the height of this plane. But if I drop down here, it's then tracking the height of my character through this section of the level. And then once again, come up here, it will lock the height. And I can also look around with the mouse or the gamepad. So if I press the right stick on the gamepad, I can also look down off of ledges, for example. And if I jump down here, once again, it's following the height of my character. And we can also go over to a wall, and it's detecting the wall and sort of stopping the camera from moving too close into the wall. And you'll also notice that when I run around, the camera is offset slightly in front of my character wherever my character is facing. This is super easy to set up, and yeah, it's a very, very cool, fully dynamic and procedural camera system so that you can customize the behavior of your camera throughout your levels to act differently depending on what part of the level you are in. But just before we get started, guys, if you like what we do here at Pitchfork Academy, the #1 way to support our channel is by checking out our new game, Skyblocker, which we've just released on Steam. It's a 3D arcade puzzle game where you stack blocks as high as you can to try and get a high score while battling the elements and gravity. But without further ado, let me show you how to do this. Alrighty guys, the first thing I'm going to do is create a new project using the third person template, leave everything as default, name it whatever you like, and hit create. And now that the editor's fired up, let's make this game act more like a 2.5D side scroller. So if we select the player start here in the level, and if you pay attention to the gizmo down in the bottom left here that shows the X, Y, and Z axes, we will basically be running along the X axis, and the Z axis will be our sort of up and down, and the Y axis we will not be using. But we will be running sort of left to right this way. So the first thing I'm going to do is press E on the keyboard to select my rotation gizmo and rotate this player start around 180 degrees. And actually, you'll see in the details panel, sometimes this will not be exactly 180 degrees, but you will want to set this to exactly 180 degrees like so. And I might just move this over to the left a little bit. And so basically we want to set our character up to run left to right here, have the camera over this way looking in, and we'll also constrain them so they cannot use the Y axis and they just run sort of left to right. So let's head on down to the third person folder and blueprints and open BP third person character. And FYI guys, I am using Unreal Engine 5.5 here, so you may see some differences, such as here in the add input mapping context section. But don't worry, I'm going to set this up to look more like the template in the older versions of the engine. And the first thing I'm going to do here is delete these first two nodes, and I will grab event begin play. I'll also get player controller, promote this to a variable, and I'll just call it PC for player controller. And we'll plug this in here, plug the PC into the enhanced input local player subsystem, plug in the execution pin here. And if you don't have this section, don't worry, as long as your input is working, that's all that matters. But you will need event begin play, so at least add the event begin play, the get player controller, and promote it to a variable, because we will use that in a moment. And I might actually just extend this section a little bit, move these out, and I'll drag off of event begin play and press S to get a sequence, because we're going to be adding more to this section shortly. But for now, I'm going to compile this and head to the viewport. And the first thing we want to do here is select the camera boom. And in the details panel, we want to uncheck use pawn control rotation. If we uncheck use pawn control rotation, that will then allow us to rotate the camera boom. And we basically want to rotate the camera boom 90 degrees clockwise, like so. And we'll also select the character movement component and search for constrain. And we'll check constrain to plane, and the plane constraint normal right here will change on the y-axis to 1, and that will stop our player from moving in the y-axis. We'll also head to the event graph and we'll change the inputs here a little bit. The camera input we are not going to need, but we are going to use the IA look to set up a kind of looking around mechanic later on. But we won't need these add controller yaw and add controller pitch input nodes, so we'll just delete all of that. And we also need to change our movement input here. So we're basically going to be using our forward and backward movement, because the way that this world direction is calculated works well for us and the setup that we're going for, but we're not going to need this left and right stuff, so we can actually select all of that and delete that. And then I'll grab this stuff and move it in a little bit, plug in the execution pin. And the other thing we need to do here, instead of using the Y input, is use the X input. So grab the action value X and just plug it into that reroute node, and that will now allow us to move left and right. And that's because this X value is basically our A and D, our left and right. But this world direction will work correctly for that. And basically the only other thing we need to do is select the camera boom and change the rotation right here to world, and this will change to absolute rotation. And while we're here, I'm just going to set this to exactly 90 degrees like so. And now if we hit play, we've basically got a side scroller. We can run left and right, jump up and down, but this is quite slow. Doesn't really feel too much like a 2.5D platformer, or any kind of platformer for that matter, because we kind of want to have a bit more snappier movement. So there's a few things you can do to make this a bit snappier. We'll select the character movement component here, and we'll search for gravity, and we'll change the gravity scale to something a bit higher, like 3. We can also find our max walk speed and change this to something like 800. And if we find our jump falling section down here, we could also change the initial jump velocity to something like 1200. And I might change the braking deceleration falling to 1800. And let's crank air control all the way up to 1. And this will basically mean that we have full control while we're in the air. And if we let go of any keys, our character will basically stop moving laterally whenever we let go of A or D. So if we hit compile now and have a look at how this plays, we can run a lot faster. We've got a bit more of a snappy jump. And if we let go of our directional keys while we're in the air, our character will sort of slow down and stop a lot more, and we have a bit of control in the air as well. You can keep fiddling with this stuff. Obviously, if you're going to make a whole side scroller, you will want to, have your character movement set up just so to give the player the feel of, whatever you're going for in your game. Now, you will notice, guys, if you didn't rotate the player start, for example, if I rotate this back around to face its original direction, our camera will still be in the same place, but our controls will be reversed here. So if you did want to set up your game to run sort of right to left, I don't really know why you'd want to do that. Traditionally you'd go left to right, and it does feel a lot more natural. But if you did want to run right to left in your game, or you just had particular levels where you ran right to left, let's add something in the movement right here to basically give you the option to make it work correctly right to left. So we can add a variable, and we'll call it flip x-axis. And this will be a Boolean, and I'll leave it false by default. But I'll just move this reroute node to the left a little bit, drag off of scale value here, and get a select float. and we'll use flip x-axis as the condition here. And if we don't want to flip the x-axis, we'll just plug this straight into B, like so. And if we do want to flip it, we can drag off of here and multiply this action value x by -1. So we'll negate it if you want to flip the x-axis like so. So now this will work just how we set it up. Left is left, right is right. And if you want to turn this player start around to have a rotation of 0, you can set this flip x-axis to true, and that will work that way as well. But I'm not a psychopath, so I'm going to set my platformer up to run left to right, and I will uncheck flip x-axis. Alrighty, let's now set our platformer camera up. And this is quite involved. Spent a lot of time working on this system to get it working nice and smoothly, but it is pretty much a full procedural side-scroller camera that works very nicely indeed. So basically what we're going to do is create an actor, which will be our camera with our camera boom, and we'll sort of move that actor depending on how we want our camera to behave. So let's just do it in the third person and blueprints folder right here. I'm going to right click, create a new blueprint class of type actor. We'll call it BP_camera. And what we'll do in our third person character is grab our camera boom and our follow camera. I'll press Ctrl X to cut these from here, and then I'll open up my BP camera. I'll select the default scene route and Ctrl V to paste those in. And now these are basically in this separate actor. While I'm here, I might select my spring arm and change the target arm length to something like 800. And we'll also create a reference to our third person character, which we'll set when we spawn this camera. So let's add a variable and we'll just call it character. And I'll drop this down and look for third person and set this as a BP third person character object reference. And we'll also set that as instance editable and exposed on spawn. And then if we compile this, head to our third person character up here on event begin play, we'll drag off of the next execution pin on our sequence and spawn actor from class. And this will be our camera, BP camera. And the spawn transform, we'll right click on this and split the struct pin. And for the location, we'll get the actor location of our character. And I'm going to basically add a height offset to this. So I'll add, and then I'll right click and split the struct pin here. And we'll add on the z-axis something like 100 units. This will be good for now. So we'll make this 100 units and I'll promote this to a variable. I'll call it default camera height. So we're basically going to spawn this camera 100 units above our character. We can plug this into the location. And here is the character variable that we created, and we'll just pass through a reference to self. And that is just in case we need to pull anything from our character inside of our camera, we'll have a reference to this character in there. And vice versa, we'll create a reference to the camera in our character by dragging off the return value and promoting this to a variable. I'll just call it camera. And the only other thing we need to do here is basically essentially possess this camera with our player controller. So we can grab our PC variable right here, and off of that we can find a node called setViewTarget with blend. Plug this in, and we don't really need to change anything on this node, but I might just check lock outgoing. And this also needs a target, and we can just plug our camera into that target. And the only other thing before I forget is we probably want to turn the collision test off on our camera boom more specifically. So just select the spring arm in your camera and uncheck do collision test. And this just means that when you're moving around and you pass an object, for example, the camera won't sort of do a collision test on this and push the spring arm forward like this. You generally want your camera to sort of stay at a fairly consistent range from your character, and you also wouldn't want the spring arm to collide with your character itself. So if we hit play now, we've got our side scroller camera, but it obviously doesn't follow our character. So let's make this camera follow along with our character. To do that, we'll head into our BP camera and go to the event graph, and we'll do this on tick. We'll add a function and we'll just call it update camera. And in the event graph, we'll call it on event tick. So drag out update camera and call it here. And then in update camera, we can drag off of here and set actor location. And to smooth this out a little bit, we'll get a v interp2. And just before we set up the current and the target vectors here, we'll drag off of delta time and get world delta seconds. And the interp speed will set to something like 7.5. And you can drag off of this and promote it to a variable, and we'll just call it camera interp speed. And this is basically how fast your camera will update to, go into the target location. So the lower this is, the more sort of camera lag you'll get, and the higher this is, the more snappier your camera will move around. The current location, we can just get actor location. Whoops, if I could type, get actor location. And for the target, we can duplicate this get actor location and grab our character reference, plug it into the target here. So we'll get the location of our character. And I'm going to add the default camera height that we set in our character. So you can get the default camera height, this variable that we created. And I will add this to the z-axis. So I'll right click on here and split the struct pin. And the z-axis, I will add that default camera height. And we're going to add a lot more to this in a moment. So I'm just going to drag off of the target here and find an add node. And I'll right click the first pin here and split the struct pin. I'll plug the X into the X, the Y into the Y, and the Z will be our Z plus our default camera height, like so. I'm going to leave this at 0 for now, but we are going to add a whole lot more and some more options to this in a moment. But this will basically now follow our character. So if we hit play, it follows our character, and we've got that nice little bit of camera lag and catches up like so. Very, very nice. But one thing we can do to make this even nicer is basically make the camera move in front of our character a little bit. So whichever way we're facing, the camera will sort of jump out in front of our character. And you can see here my character is sort of not centered in the viewport, and that's just because I've got a widget reflector for the tutorial to make all of this stuff a little bit larger, and it sort of makes the image offset. So if I don't full screen, it's actually not offset. So I'll try not to full screen so it doesn't look weird for you guys. But let's make the camera move just in front of our character a little bit. And this is super, super easy. This is why I left this addition right here. We can just get our character reference. I'll duplicate it down here and get actor forward vector. Get actor forward vector, and I'm going to multiply this by how many units I want this to sort of sit out in front of my character. So I'll right click this pin and convert it to a float, and let's just make this something like 100 units for now, so the camera will stay 100 units in front of the character. And I'll promote this to a variable, and I'll call it camera offset or something like that. Camera offset. And we don't actually want to use the y-axis of this vector. When our character turns around, we don't want to use that y-axis. We're only doing this on the x and the z-axis. So we can right click here, split the struct pin, and also split this struct pin up here, and I'll plug the X into the X and the Z into the Z, and it is as easy as that. The camera should now be 100 units in front of wherever our character is facing. Very, very nice. The next thing I'd like to add is the ability to lock the camera height. So at the moment, when I jump, the camera is just following the character up and down, and you may not always want it to do that. So we're going to add the option to basically lock the camera to a particular height. And I'll also show you how to change that height at runtime. So you can set it up so different parts of your level might act like this, and then other parts, the camera won't follow the character up and down. So let's set that up now. So I'll create a Boolean in my third person character, and I'll call it should lock height, or something like that. Should lock height. I'll compile this, and I'm going to set this to true as default because I quite like this mechanic. And I'm also going to add a variable which is the sort of height target that we want our camera to have. So I'll call it camera Z target, and this will be a float. And the default value of this, we basically want it to be the height of our character on this plane right here. So if I just drag out this BP third person character, right here you can see in the third argument of the location, this is 90 units up. So we'll set this as the default for now. I'll select that 90 and just Control C. We can delete that character, and then we'll paste that value into the default value of the camera Z target. We'll head on over to our BP camera, and I'll move this stuff out of the way a little bit and move this stuff out. We'll add this right here, and basically what we're going to be doing is using that Boolean to decide what we want to set the Z value of the location of our camera as. So we can drag off of the Z right here and find a select float, and I'll drag off of my character reference here and get should lock height. And if we don't want to lock our height, we can use what we created earlier. So we'll just plug that addition node into the B. And if we do want to lock the height, we can just grab our default camera height here and add. And what we want to add to it is from our character, we'll get the camera Z target and add that to the default camera height. So it'll be the camera Z target plus our camera height, our 100 units above the character. We can plug that into A, and if this is set to true by default in our character, it means that now when we hit play and we jump, the camera will not follow our character. We can just run along, and it acts a bit more like a traditional platformer. But like I said, I'll show you how to set this at runtime later on, so you can set it up in your levels to act this way on certain parts of the levels and act the other way on other parts of the levels. Alrighty, let's go ahead and add wall detection, because you'll notice at the moment, because the camera sort of sits in front of the character, if you go over to a wall, the camera will just go into the wall. And traditionally, you know, and just sort of logically, design-wise, you probably don't want your camera to get too close to the wall. When you get to the end of a level, for example, or the edge of a level, you want the camera to sort of slow down and stop, and then you'll sort of get the feeling that you're at the edge of the level, and it will look nicer. So let's set up some wall detection. Now I'm going to do this with line traces on two different trace channels, so that we can sort of have a bit more control over what happens when we go to the left versus when we go to the right. It might seem a little bit complicated, but this is the best way that I've found to do this procedurally. So what I'm going to do is go to Edit and Project Settings, and I'll search for Trace, and I'll add a new trace channel here. I'll call it wall, no spaces, wall trace left. and I'll set the default response to ignore, because we only want this to detect, what we want it to detect. So we'll create a volume that will block this wall trace left. So we'll set this default response to ignore and hit accept. And I probably should have Control C that name. I'll add one more trace channel, and I'll call it wall trace right. And once again, set this to ignore and hit accept. Now that we've got these trace channels, we can close our project settings. And in our BP camera, I'm going to create a new function. I'll call it wall check trace, something like that. And before I forget, in my update camera, I'm going to call this function right here on my update camera, like so. So that we have whatever we get from these wall traces we have for our camera system right here. We'll head back into wall check trace, and what we're going to do here is a line trace by channel, and I'll change the trace channel here to wall trace left, and I'll also change the draw debug type to for one frame, because we're calling this on tick, so this will basically make the line trace show up the entire time. And for the start points, we'll get our character reference here, and we'll get actor location. But I don't want to draw this from the sort of center of the character. I want to offset it by our character's capsule component here, because if we draw it from sort of close to the edge of the capsule, it will just make it easier to make it behave in a much more pleasant way. If you sort of detecting a wall from the center of the capsule, it doesn't really make sense, because the wall is inside the capsule, and if the wall is inside the capsule, then you probably don't want to detect it. So this will just make it sort of act a lot smoother. So what we'll do here off of the character is we'll get scaled capsule radius of the capsule component. Get scaled capsule radius, and this is just basically the actual radius of your capsule, and we'll multiply this by 0.9. So this is basically 90% of the way out. So it'll be 90% of the radius towards the edge, so it'll start just before the edge of the capsule. You could probably set this even higher, but 0.9 works quite well. And we'll also multiply this by the forward vector of our camera. And the reason we'll use the camera is because it's always going to stay in the same sort of orientation. So this is the way that I've figured out to make this sort of work most consistently, is we will get actor forward vector, and I'll add another pin to this multiplication node here, and I will multiply. So basically I'm multiplying the forward vector by 0.9 of the capsule radius. So this gives us it comes out 90% of the way of the capsule component, like so. And if I add this to the actor location, add this here, plug it into the start, and I'll make my left, my wall trace left, I'll drop this down and I'll make the trace color blue. And the endpoint of the trace, we will basically multiply our forward vector by a certain amount. So we'll multiply this, I'll right click here, convert this to a float, and I'll make this something like 400 units. So we'll check for walls 400 units out from our character. And you can promote this to a variable, and we'll call it wall detection radius, maybe, because we're doing it in multiple directions. Wall detection radius, and we'll add this to our actor location. So once again, we'll add this to our actor location, and this will be our endpoint. And to double check, before we do our wall trace right, we just want to double check that this is indeed tracing left. So if we hit play here, we should have a blue line coming out the left side of our character. And you can see it doesn't start at the center of the character, it starts a little bit out, and that is just near the edge of our capsule, and it is detecting left 400 units. Nice. So that is going in the correct direction, and if that is not going in the correct direction for some reason, your camera's forward vector is different, you may just want to basically change the trace channel, or you can also just replace these with subtract nodes instead of addition nodes, and it will change the direction, which is what we'll do for our line trace right. So we'll grab this line trace by channel, we'll duplicate it down here, and we're basically just going to do the exact same thing, but replace these with subtract nodes. So we can drag off of the get actor location, get a subtract node, and we can duplicate that, also plug it into get actor location. And for the start, we'll subtract this first multiplication node, plug that into the start. And for the other one, we'll subtract this other multiplication node, plug that into the end. And we'll change the trace color to something like yellow, so it's different. And I'll plug in the execution pins here and just double check that that is working. Yep, it's tracing to the right with a yellow line, tracing to the left with a blue line. Nice, that is working as expected. I'll actually disconnect this execution line because we're going to take the return value in the out hit and we're going to basically promote that to a variable. So let's drag off the return value here and promote to variable, and we'll call this wall detected left. And I'll duplicate that variable, Control D, and I'll call the other one wall detected right. And I'll set it down here, like so. And actually, we'll move both of these out a little bit. We'll drag off the return value and press B to get a branch. And we'll set this as true if we have hit something. We'll do the same down here, add a branch, and disconnect this and check this. So we'll set it to true if we have hit something, and then we'll duplicate both of these, move them down a bit, and if we don't hit something, we'll set these as false, and then we'll drag off of the out hit here and promote this to a variable, and we'll call this wall detect out hit, and plug this in like so. And whether we hit something or we don't, we want to run this other line trace. So we'll plug this in down here and grab a couple of reroute nodes like so. And I'll plug this onto the reroute node. And down here, we'll also set our wall detect out hit if we hit something. Whoops, plug this in here and plug the out hit in. And I just want to clear this wall detect out hit if we haven't hit anything. So if we get to this second line trace and it doesn't hit anything, what we can do is grab our wall detect left and our wall detect right, and we'll get an OR boolean. Plug this in here, and we'll also get a not boolean. So if we have not hit wall detected left or wall detected right, we'll grab a branch, whoops, and we'll set our wall detect out hit as null, as nothing. Nice. And now that we've got these wall detections, we'll actually need something to detect for starters. So let's go ahead and create our wall volume. This is pretty straightforward. We'll right click in here, create a new blueprint class of type actor, and I'll call this BP underscore wall volume, and open this up. And in here on the default scene root, we'll add a box collision. And I'll change the scale on this box to something like 0.025. It only needs to be really quite narrow. And I'll make this 6 and 10 to make this quite tall and quite wide, like so. And I'll scroll down here and find the collision settings right here, the collision presets. I'll change this to custom. I'll check ignore here to make it ignore everything. and then I will make it block wall trace left, like so. And the only other thing we need to do is basically change this if this is a right wall. So we can add a variable here. We'll call it right wall, question mark. Compile this, head to the construction script here, and we'll grab our right wall variable, drag off of this and press B to get a branch. And if it is a right wall, we can change the collision settings of our box. So I'll grab my box here and we can find a node called set collision response to channel. And the channel that we want to change first is our wall trace left to ignore. We can duplicate this node here and make sure we plug in the target, and then we'll change wall trace right to block. Plug this into true right here, and we'll duplicate both of these, plug in the execution pin, and plug in the box as the target, and we'll change this from wall trace left to wall trace right, and from wall trace right to wall trace left. So this means we can place this volume and we can just change this variable and it will change the collision response here. So first we want to make sure that we select our right wall variable and we change it to instance editable. And then that way we can just drop this wall volume on the level and it will by default be a left wall. And if we drag it out over here and we check right wall on this one, that means that our left trace will detect the left wall and our right trace will not detect the right wall. What have we done there? I suspect I forgot to change the trace channel right here on our wall check trace function. So we want to make sure that the trace channel on this second one here is set to wall trace right, like so. Sorry about that, guys. Now our blue trace should detect our left wall and our yellow trace will detect our right wall. And if we step through this volume, the blue trace will not detect it. And if we step through this volume, the yellow trace will not detect that one. So that is working now. And now that we have these wall volumes, I'm just going to move them into the actual walls over here. And these don't need to be exact, but just inside the wall like so. And this should work just fine. Then what we can do is head back to our camera and our update camera function, and down here where we kind of add our camera offset, we can multiply this and sort of manipulate this offset, the horizontal offset, depending on whether we are detecting a wall or not. So let's add another pin here. I'll right click and convert it to a float, and I'll drag off of here and get a select float. Whoops, select float. And the condition for this is whether we've detected a wall, left or right. So let's get our wall detected left and our wall detected right. We'll get an OR boolean, plug these in, and plug these into the condition. So if we've detected a left wall or a right wall, this will pick A. And if we haven't, it will pick B, and we can just set B as 1. So it will make no difference to this. If we have not detected a wall, it will just multiply it by 1. And if we have detected a wall, what we can do is get our wall detect out hit. We can right click this and split the struct pin. And what we want from this is the distance to the detected wall. So we can drag off the distance here and find a map range clamped. And this basically takes the input in a certain range and outputs it in a different range. And what we can do is set the in range A from our wall detection radius. So this is, as you remember in our wall check trace, this is how far we are drawing these traces. So this is the max distance that we can detect a wall, and we'll use that as the in range A. The in range B can just stay at 0. So we're going from range 400 down to 0. And what we will output is 1 to -1. And if we plug this into the A right here, basically what this means is that at the maximum range that we detect our wall, our offset in front of our character will be multiplied by 1. And if the wall is 0 units away, it would be multiplied by -1. So the camera will sort of go behind us a little bit. And you'll see this in action if I go over to the wall. As soon as I detect the wall and I start getting closer, the camera will not move as far as the character. And now the camera is on the left of the character. But there's one other problem here, which is when we turn our character, because that offset is being multiplied by -1, it sort of moves into the wall, which we don't want. But it is working there. You can see our character can get close to the wall and the camera is no longer going into the wall, but we just need to basically clamp how close to the wall it can get. And this will be a little bit of spaghetti code. I will grab all of this stuff here and just move it out here, get it out of the way a little bit, because what we're going to do now if we detect a wall is basically clamp the X of this vector so that our camera can only move so far. So we can drag off of the target here on our vinterp2 and we can get a select, and this will be a select vector. And the condition, once again, will be the same condition as here if we've detected a left wall or a right wall. So I'll duplicate these up here and plug them in here. So if we haven't detected a wall, it will select B. And what we can select is just the output here of this addition node. And if we have detected a wall, what we can do is drag off of the A here and we'll make a vector, make vector. And I'll also drag off of here and break vector. And this is just the same as splitting a struct pin like we have here. So this is just splitting this into the X, Y, and Z. And then this is recombining it over here. But all we want to manipulate here is the X axis. So how close to the wall we want the camera to move across. So we can plug the Y and the Z straight in like so. And then off of the X on the make vector here, I'll find a select float and I will get wall detected left and plug it into A like so. Now this will only be used if we detect a wall left or right. And then if we just check if we've detected left, this will tell us if it is left or right. So we'll plug, the left logic into A and the right logic into B, if that makes any sense. And basically what we're going to do is grab our wall detect out hit, right click this and split the struct pin. So this is our hit result from our wall detection. And we are going to use the location of the hit. So the world location of our wall, and we'll use that to clamp sort of how close to the wall our camera can go. So we can right click on this location right here and split the struct pin, and wall hit location X is what we are interested in. And for our left wall, we can drag off of here and get a subtract node. Now this will get a little bit spaghettified. This will be spaghetti code, but trust me, if you follow along, it will work just fine. Basically, what we want to subtract here is our camera offset multiplied by a certain amount. So I'll grab my camera offset here and I'll multiply this by, let's try 1.5. Now, I've tried some different values here. If you make this too low, the camera will be able to get a little bit too close to the wall. If you make it too high, it will also not have some great behavior. But basically what I'll do is I'll subtract this camera offset multiplied by 1.5. I'll also add a pin here and I'll get my character reference, because you want to factor in the radius of your capsule. So we'll grab the character and we'll get scaled capsule radius of the capsule component, get scaled capsule radius. And I'll try and keep this as neat and tidy as possible. but we basically want to also subtract the capsule radius because that's as close to the wall as you can possibly get is the capsule radius. And I'm going to drag off of the X right here and get a clamp, and this will be a clamp float. And the maximum here will be the output of this subtract right here. And for the minimum, we don't really want this to be 0. We want it to be relative to, the wall and the location of our character. So we can just subtract off of this, and we can subtract, quite a big number. Like, I'm just going to make it 1,000,000. And that will, make sure that the minimum of this clamp basically doesn't interfere with our camera whatsoever. We can plug this into the A on the select float, and we basically want to do the same for a right wall, but we're going to want to add this stuff instead. So we can drag off of location X here, and we can add, and we're going to add the same stuff here, the camera offset multiplied by 1.5. We'll add a pin, and we'll also add the scaled capsule radius, and we'll duplicate this clamp float, plug the X into the value, and this time, instead of this figure being our max, it will be our minimum. So we'll add this to the minimum, and I will also drag off of here and add, and once again, add big number, 1,000,000, just to make sure it doesn't interfere whatsoever. Plug this into the max, and then this will plug into our B on the select float here. And that's it. I know it's a little bit spaghettified down here, a little bit hard to read, but you should be able to put this together. And this means that when we detect a wall on the right, the camera will sort of slow down, and then it will stop. It will not be able to get any closer, which is a really nice effect. And then if we move away from the wall, our camera will move away from the wall like so. And it should work the same over here for a left wall. We get nice and close, and then we're here next to the wall. And this is just because my volume doesn't extend high enough. So it's a bit hard to see my volume. I might just move it there. There we go. And move it up, and make sure that this is blocking as high as I need it to block. See if I can get this volume, make it visible, and move it up. And there we go. Nice. And now we get to the wall here, and it's kind of like we're at the edge of the level. Our camera will not move any further. And we move out, and it's nice and smooth. Very, very nice. And that's working on the right-hand side as well. Okay, now what if you wanted to have it so that when you move through your level, you can change stuff like the target Z, change the height of the camera, and also unlock it so that it follows the character, if you like. So we'll do that using a volume. Once again, we'll create a new blueprint actor. So right click here, blueprint class of type actor, and we'll call this BP underscore height volume, something like that. And we'll open this up, and we'll select the default scene route and add a box collision. And I'll select my box and scroll down to the collision settings here, set these to custom, and I'll set this to ignore everything except for the pawn. It's the only thing we need this box collision to check for is our character, so we'll set it to overlap pawn. And we'll create a couple of variables here. We'll call one new Z target for our new camera height. This will be a float. And we'll also create one called should lock height. And this will be a Boolean. Both of these need to be instance editable, so we can change them for each volume we place in the level. So select new Z target, make it instance editable, select should lock height, make it instance editable. And then what we can do is select our box and scroll down and find on component begin overlap and add this event on component begin overlap. And we'll drag off of other actor here and check if actor has tag. and we'll check if it has the tag player, which we'll need to add this tag to our player. Drag off the return value here and get a branch and plug this in. And then we'll add this tag to our character. So I'm just going to Control C this tag to copy it, head to our BP third person character and search for tag. Add the actor tag. If you only see a component tag here, you might have a component selected like so. Just select the root and make sure you're adding it under actor tags right here. So add an actor tag, paste in player, and now we can check if the player has overlapped with the box volume, but we basically need a way of sending that new Z target and the should lock variables to our character. So we'll use a blueprint interface. We'll right click here and create a new blueprint interface, and I'll call this BPI underscore, I'll just call it character because it's going to interface with our character. I'll open this up, and the function right here, I'll just call it set new camera values or something like that, and I'll give it an input, and this first one will be new Z target of type float, and one more which will be our should lock height. Whoops, I knew I'd stuff up typing height, and this will be a boolean. We can compile and save and close this, and then we need to add it to our third person character. So go to BP third person character, class settings up here, and in class settings under implemented interfaces we'll add our BPI character like so. And over here under interfaces we can double click our set new camera values. It will bring up this event for when we call this interface, and all we'll want to do here is set our camera Z target and set our should lock height as what we pass through. So set it as this and as this. Make sure you plug these in, and then we can go back to our BP height volume, and off of our other actor here we can call our set camera values, set new camera values message, and we'll interface with our character and we'll send over our new Z target and our should lock height. And this will be working now, but the only other thing we want to do is make sure that these are set if we start overlapping with a box. As in, if we dragged out our height volume here and I scaled this up like so, and we started inside a volume, we would want to make sure our character takes on those values of that volume, so we start with the correct settings. And we can do that on begin play in our BP third person character. So we'll go up here and I'll make a little bit more room, and I'll move all of this stuff out and add a third pin to our sequence. And basically what we want to do here is get overlapping actors, and we'll filter for the type, what did we call it? BP height volume. Drag off of overlapping actors and get a copy. And we actually want to check if this is valid because we don't want this to fire if it's not valid. So get one of these is valid. We'll plug that into that third pin on the sequence. And if it is valid, we want to drag off of the get here and get our new Z target. And we also want to get should lock height. And we want to set these in our character like so. Nice. And now that should be working now. We can basically, I'm going to delete this volume, and let's just alter this level a little bit so we can, sort of make some different height and sort of play around with these height volumes here. So I'll grab this ramp actually, and I'll just move it out so it's in line with our player start, like so. And I'll move this over a little bit. I'll also scale it up on the X and the Z axes if I can actually get those working. And I should be able to jump over that wall from there. So I'll just double check that I can run up here and I can jump up here. Very nice. And I'll make sure that this wall volume here is not too high. I'll just have it come up to the edge of the wall like so. And I'll scale up this wall so that we have something to jump up onto. Very nice. And I'll want a new height volume up here. So I'll grab my BP height volume, drag it out, and you'll want to scale these up so that you get the desired behavior. So you basically do not want to be able to get up here without touching the height volume. So we'll put it very close to the edge here, and I'll scale it up nice and high so we can't get past it, like so. And now we want to set the new Z target and the should lock height right here. Because we made this instance editable, we can set this for every height volume that we place in the level. And how you want to find this new Z target height is the same way that we found the height down here by dragging out the third person character. We can drag out the third person character here, and you'll see that the height of this platform right here is 490. So we can Control C that 490, delete the character, select the volume, and paste 490 into the new Z target like so. And I'm going to leave should lock height as false just to double check that that's working. So if I hit play now, the height is locked while we're down here. And if we jump up here, the height will come up, and now it is unlocked. So it is following our character. And if we duplicate this volume, so I'm going to hold Alt and click and drag and put one of these down here. And a good tip here is you don't really want to be able to overlap both of these volumes at the same time if you're only going to have two volumes like this. So putting them just beyond the corner, so this one up here is just left of the corner, and the one down here is just right of the corner. This is a nice little way of separating these so to make it very, very unlikely that you'll touch both at once. Because basically, if you go halfway between them and then you come back, it won't sort of reintroduce the properties of this one down here. So this one down here will set to the 90, which was the height of down here. And I'll set this back to, actually, I'll set this one to not lock the height. And I'll make it a bit bigger so that it overlaps with our player start. So this one will not lock the height, and this one will lock the height. So when we hit play now, you can see it's taking on the properties of that volume, and it's not locking the height. So it's following our character up and down like so. And then if I jump up here, it's changing to the new height, and it is locking the height. If I jump back down here, height's unlocked. And we've got our wall detection there. Very, very nice. The last thing I want to add with you guys is the ability to basically look around with the mouse and with the right thumbstick of a gamepad. So for example, if you came up to a ledge like this and you wanted to look down and see what the level is like down there before you jump down, we'll add the ability to basically look around. So we'll head back to our BP third person character, and this camera input with the IA look right here, this is what we will be using. I'll move that, grab these and move them out, and I'll make a bit more space here. And we're going to need a variable here. So I'll create a new variable. I'll call it something like look vector, and this will be of type vector. And what I'm going to do is set look vector when we trigger our IA look. But to basically make this act smoothly in a way that we want it to, we're going to accumulate on this look vector. So we'll get our look vector and we will add. And what we're going to add is basically the X and Y values of our look right here. We can drag these off and make a vector. We'll plug the X into the X and the Y into the Z, because that will make it move up. And we'll plug this in here and we'll add it, and then we'll set the look vector. But actually we want to clamp this and how far, because this will just, every time you move the mouse or the right thumbstick, it will add, and we want to basically clamp how much we add onto here. So we can drag off of here and get a vector clamp size max. And we'll make this something like 15 for now and plug this in. And then we'll also add a kind of reset here. So if we drop this down and off of cancelled, we can find a set timer by event. And we'll also plug in completed. So on cancelled or completed, we'll set this timer. And I'm going to make this something like a quarter of a second, 0.25. So basically, if you let go of look, a quarter of a second later, it will sort of recenter itself. And this works great with gamepad, but if you were going to set this up to work really well with mouse, it's a little trickier than that. But I'll just basically give you the basic functionality here. We can also create a custom event here, and we'll call it reset look vector. Plug in the delegate pin into the delegate pin of this custom event, like so. And all this event is going to do is set our look vector as 0. But we'll also drag off the return value here, promote this to a variable, and we'll call this reset look timer. And whenever we make an input here, we want to invalidate this timer, just so that it doesn't continuously reset while we're trying to look around. I just noticed that I missed an E there. Reset look timer. We'll get this reset look timer, and we'll clear and invalidate timer by handle whenever we make an input, like so. And that's it. This will set this vector, but we just need to add this to our camera logic. And that's really, really easy. Head over to our camera, and then right here where we're adding all of this stuff together, which is basically our actor forward vector for our offset, we basically want to add our look vector as another offset here. So we can just add a pin, and we'll get our character reference, and we'll get our look vector, get look vector. And we also want to multiply this just to basically scale it up a bit. We can right click here and set this to a float. We'll multiply it by 10 and plug this in. And that's literally it. That will add our look vector to the offset of our camera. But you will notice that there are some issues with the direction. So if I move this around now, it is exactly opposite what I want it to be. And I'll try this with gamepad as well. And yes, with gamepad, it is exactly opposite as well. So I'll show you how to fix that. What you can do is head to your input folder here, and in your IMC default, we'll drop down the mappings, and we've got our IA look. We can drop this down and drop down both the mouse input and the controller input. And you'll see if you drop down the modifiers on the mouse input, there is a negate modifier here. And if you drop down the negate modifier, you'll see it is just negating on the y-axis. And basically what we can do to flip this around is just uncheck the y-axis and check the x-axis. And now that will be working correctly. But we also need to negate as a modifier on the gamepad input. So we can drop down the modifiers here, and you'll see we've got dead zone. We don't need to touch the dead zone, but we'll add one more modifier, and that modifier will set to negate. And if we drop that down, it's got the X, Y, and the Z axis all checked. and that is fine. That should be working like so. So just make sure that you negate the x-axis on the mouse input and not the y-axis. And then on the gamepad, you negate all of the axes like so. So if I hit play now, I can look around with my mouse, and that resets like so. And if I pick up my gamepad, I can also look around, and it's a little bit slow on the gamepad. You might want to change those multiplication numbers to make it a little bit snappier. But the good thing about gamepad is wherever you hold it, the offset will stay there until you release the stick, and a quarter of a second later, it will reset like so. So that's pretty nice. That works quite well with the gamepad and also with the mouse as well. Now that's pretty much it, guys, but I've jumped over into my example project. So this is where I prototyped this system, and I just wanted to show you a bit more with what you can do with these height volumes. So if we take a look at these height volumes right here, you can see we've got 3 in this section right here. We've also got height volumes on these upper sections, and this is not quite lined up the way that I wanted it. I'll just move this over a little bit like so. And basically down here, if we select these, you'll see that we've got should lock height set to true. But what I can do is I select all 3 of these and set should lock to false. And by the way, the new Z target is irrelevant if should lock is set to true. So these 2 instance editable variables that we created are kind of mutually exclusive. You should either want to set should lock to false, or you should set a new Z target. So with should lock set to false, it will follow the character, and with it set to true, it will go to the new Z target height, if that makes any sense. So with these set to false, basically what it means is I've got this little part of the level here that goes up and down, and it follows the character through this section. But then when I come up here, it's locking, and it's staying at that right height. As soon as I drop down here, it's following the character again. And if I drop down here, what have I got over here? I've got it to lock down here at this certain height. So depending on your level design, you basically want to create these volumes throughout your level so that the camera acts however you like, you know, around the level. And another example here is I've got a wall volume, but as you can see here, it is kind of inset into the wall. And that's because I want the camera to get a little bit closer to this wall because of the height of my ramp here. You know, if I was only stuck down here, I'd want it to act normally. I'd put this height volume, you know, roughly at the edge of the wall. But because of where I've got that ramp, I've basically inset it into the wall. I've got no wall volume here at this wall because obviously I'm not able to approach the wall. And then over here, I've got this wall volume just inside the wall so that I can get a little bit closer. And you can see I've maybe put it a little bit too far inside the wall there because the camera is clipping through the wall. So I might just want to move that a little bit closer to the wall. And then, yeah. So yeah, it really just depends on how you want your level to be set up. So I've got these volumes down in this section to unlock the camera because I've kind of got a lot of change on the Z-axis happening down here, and I wanted it to follow the character. But I could also set these to just change the height. And so I'll select all 3 of these and I'll check should lock. So we'll lock to the actual height. And you can see I've got different heights here. This one's at 200. This one's obviously set to lock up here at this height. So this one goes to 200. This one down here goes to 90, which is the ground level. And this one here also goes to ground level. So when I jump down here, it will go straight down. But then I've kind of got a step up and down here. So this is locked to a height. But then when I step up here, it's locking to this new height. Come down here, it'll go back down, back up. and up to the top here. So you can set this up however you like to sort of drop down different heights. Boom, another level and another level. And then up here, I'll have it just come straight up to this level like so. Very, very nice. So yeah, I just wanted to quickly show you guys what you can do with these volumes to sort of customize the behavior of your camera throughout a level. See that wall detection working very nice there. I think that's super smooth. Very, very nice. And that's it, guys. If this tutorial has been of any use or value to you whatsoever, please hit like and subscribe, and I will see you on the next one.